Hey guys, welcome back to another video. Today I will be walking you through how to pass the Certified Kubernetes Administrator exam. This is an exam that I recently took, so I want to share with you the experiences that I had and the strategy that I employed to pass the exam on the first attempt. So I think this will definitely help anyone who's looking to attempt the exam anytime soon, so stay tuned. So let's quickly overview what the exam looks like. It is 120 minutes long, so 2 hours. There is a free retake available when you order through the Linux Foundation. I will have all the relevant links in the description, so I will link where you can order the exam. One hot tip is that if you're around the Black Friday, Cyber Monday kind of time, then you should look at waiting until Cyber Monday to order, because you get it for half price. That's what I did. I ordered it back in November and sat the exam just before the new year, this year 2023. So the first thing that I would advise that you do is to start to think about time management, because there are 15 to 20 questions that can be a reasonable level of complexity. So it is worthwhile for you to have a setup and have a strategy to reduce the time that you are taking in each question, so that you can get to the end with some time to spare and then review your questions, any of the questions that you thought maybe needed a second run over. As I said, it's a 2-hour exam, 15 to 20 questions. And the first step of that strategy is to have a good setup going into the exam. And really what this revolves around is your bash RC. You should have a couple of shortcuts, maybe even a function here or there that will make it easier for you to navigate through the exam, so that you don't have to retype out long commands over and over again. So this is the setup that I used. I might put a link to a GitHub gist in the description as well, but it's not too complex. So you go into your bash RC. The first thing you should look at doing is having an alias for kubectl. So alias k equals kubectl. We can also put an alias in there for vim. These are the two commands that you will be typing most regularly. It'll probably be, 100, 200 times in the exam that you will type to kubectl. So there's no need really for you to be typing that out over and over again. If you're not the best typist, then you might have typos and you have to go back and you have to correct what you're doing. Just put your alias in there one time and then you're finished, and it's going to probably save you a couple of minutes throughout the course of the 2-hour exam. The next thing that I would include is a function for setting the default namespace. So this is what I did in the exam. It essentially makes it easier to switch between namespaces as you're working through the exam. You may be, for a particular question, they'll generally give you a specific namespace that you should work in, and so it makes sense for that question, however long it might take, 10-15 minutes, for you to be working in that specific namespace, not have to type out -n and whatever the namespace is with each kubectl command that you issue. So the function that we will define is kubectl config set context --current -- namespace equals $1. So that means that when we type ns and then pass the namespace that we want to work in, it will run this command and specify the namespace here, and that'll change our local config so that we're using that namespace. Next, when we are running commands, we will generally want to run them imperatively. We don't want to set up a basic pod. We don't want to go away and write a full pod manifest. We can do that much easier if we just use kubectl run. Something that will aid us here is the ability to use dry runs. So I will set an environment variable, drc equals -- dry run equals client and -o YAML. And we'll see how this is used in a second. But we can also do a server dry run, and we just have to specify server here. And that is us essentially for our bash RC setup. Now we're ready to start the questions in the exam. And as I mentioned, one of the big things that they will ask us to do is to just create pods in various ways with various configuration. So first of all, let's source our bash RC. There we go. And if we run k-help, we'll see that we now have all of the Kubernetes commands that we can run. As I was saying, it is important to run pods imperatively, and we can do that using krun. And we can specify the name of the pod, test pod, the image, nginx, and if we want to run it as a dry run, we can just pass our drc. And generally what will happen is that the exam will give us the image, and there may be some extra criteria that we have to use. So we'll take this manifest that has been generated from our imperative command, we'll use this vim test.yaml, and we can just paste that in there. And now anything we need to do, let's say we need to add a volume, and we can just go volumes and so on. There's some, content under there, and then we can apply it using kubectl apply. So that's the basic approach that you want to use. You want to use imperative commands. If you need to modify the basic imperative output, then you can use your $drc environment variable that you've set at the beginning of your exam. Now, there are a few basic Vim commands that I would recommend that you're familiar with. So the first one, set nu. This sets line numbers. It makes it easier for you to jump between the files. So if you want to, let's say you want to go to where the restart policy is defined, just do :16, and then you jump to the line you want to get to. Another one, when you're working heavily on the manifest, you may want to do auto indent, and that will essentially mean that when you create a new line, it will tab over to the level of indentation that you have already, rather than bring you back to the start of the line. Then you have to tab over manually. It saves you a little bit of time. So that is the two kind of basic Vim commands that I utilized to make writing the Kubernetes manifests when they had to be written a little bit easier. The next one that we should look at in terms of time management is shorthand names. So we can get a list of the shorthand names using KAPI resource, and here we have all of the API resources and their short names. So instead of typing out kget nodes, we can do kget no. We can do kget sa instead of service account. You can do that. See, you're likely to get you get typos when you use the full name instead. Do kget sa, makes your life a little bit easier. As I said, you can get the resources and their short names using KAPI resources, or kubectl API resources. Now, when it comes to upskilling for the CKA and then practicing for the exam, there are a few resources that I recommend. The first one is this CKA course that I completed. It was by Mumshad Manambeth, and it was a Certified Kubernetes Administrator with practice tests. I haven't researched too many other courses. I'm sure there are plenty of very good courses out there, but I went through this. It's 22 hours in total, and I couldn't fault it, to be honest. It has practice tests that are in a similar format to the exam, so you get that feel that you will have in the exam, and it covers comprehensively all of the material that you need to know, and it's quite beginner friendly if you are a beginner. The explanations are very relatable to anyone at any experience level, in my opinion. So the next thing is that you will have access to the official Kubernetes docs. It's worthwhile you practicing with the docs. So when you run through the practice tests in the course, then you can use the docs. It's the same with the practice exams that are provided here. They're also quite useful. You can use the docs there. I did all the mock exams that are provided. There are 3 mock exams, and I did each of those a number of times until I was able to, easily pass each mock exam. And the exam is taken in a remote desktop, so you can think of this like a Linux virtual machine. You have access to a browser and a terminal, and those are all you really need for the exam. It is worth noting that you actually get links to the relevant documentation in each question. That was something I wasn't aware of, but I just used the search functionality when I needed to reference documentation. But you can actually just click through in each question and go to the relevant documentation, so that does make life a little bit easier for you. Finally, when you purchase the exam, you get 2 goes at a practice exam using Killer.sh, which is this website here, and this is probably your gold standard when it comes to any kind of mock exam. It is the questions are challenging, they're in depth, and I recommend that you go over them at least a couple of times, but I don't expect that you would pass in the 2-hour time limit. There are 25 questions given here versus 17 at least 17 in the exam that I did, and most of the questions are more complex than the questions that you will get in the exam. So obviously trying to get all of that done in 2 hours is unlikely. If you do pass in under 2 hours one of these mock exams, then I would be immediately going to the CKA and getting that done, because you'll most likely pass it. Now let's have a look at some key areas of the exam. The first one is volumes. Generally all of the mock exams and all of the actual exams will have a question that relates to volumes, so you should be familiar with how to create a volume. This obviously you can go to your documentation if you wish to, but I think it's worthwhile to just be aware of how to do it yourself. So if you want to create a pod, let's say we go back and use that example that we had earlier, vim test2.yaml, create new file. Let's say we want to mount a volume to this pod. First of all, we need to, I will set auto indent. First of all, volumes, name my volume, empty dir, size limit 10 MI. And this is a simple volume that you may get. You'll likely have a question related to persistent volumes, so you need to know how to reference those. For example, when you create a persistent volume, you'll have to define the persistent volume, define the persistent volume claim, and then mount the persistent volume claim to the pod that you're running. So that would, I'm not going to go into how to do that, but it's worthwhile being reasonably familiar with that as well, you can go to the docs for the details. So as I was saying, you should be familiar with how to, where does the volume mounts go? Where does the volume go? Volumes is under spec, volume mounts is under spec.containers. And this is something that you'll get with practice, going through the practice exams. But if you're going into the exam and you don't know this kind of stuff, it's worthwhile just spending the time going over a couple of example questions and just making sure you know these kind of basics. So name will be my vol, and mount path will be /home, for example. Now we can try to apply. Okay, apply -f test2.yaml $DRS, and we can see that when we dry run against the server, it actually is able to create the pod. So that means that we're good to go. We don't have to modify anything else, and our pod will be created and it'll have an empty dir volume. Next one is role-based access control. So you should be familiar with how to create roles, create service accounts, and create role bindings. So if we want to create a role, again, it should be done imperatively to begin with. K create role -- verbs equals create, let's say, -- resource equals pods. And then we can dry run it again just to make sure. Okay, we have to pass a name, my role, and this will create a role in the default namespace. If we want to specify a particular namespace, we can do that too. Just pass -n cube system, for example. That's an already existing namespace, so we can use that. And this is what our manifest would look like if we were to do it via manifest. But let's say we're all good with that. We'll actually just create it in the default namespace, and we just remove our dry run, and that is created. And if we wanted to create a role binding, let's say we had some new user that needed to be bound to our pod creation role that we just defined, then we would do k create role binding role was my role, k create role binding role is equal to my role binding -- user equals John. And that is created. Again, we could have done our dry run if we wanted to see what it looks like, verify everything, but obviously we just created it. And when you've created your role and your role binding and you want to verify if the permissions have been properly implemented, you can use kauth can I create pods -- as equals John, and we can see that we can. And let's say we just want to double verify by checking against some other random user. The result is no, we cannot. So that role binding that we just created and the role that we created have worked as desired. The next thing that we should look at are labels, taints, and toleration. So we should be able to manipulate labels and use them for various purposes. For example, a lot of the time this relates to nodes. So k get nodes -- labels is a -- show labels, sorry, is a useful command for us, and this will show all of the labels that are associated with each node. And we can also get -o YAML grep taints, two taints. see what the issue here is. Okay, so there are no taints on this node. That's what the problem is. But generally, control plane nodes, the fact that I'm using Minikube here is showing a different result. But generally, control plane nodes will have taints on them, and one of the questions may be to add a toleration for the particular taint. So I can show you k taint node Minikube -- effect. Let's just check the help. This is very useful when you're trying to run commands that you're not totally sure about. So let's just paste this in. Taint node Minikube. Taint. Say 3. So we can see we have this taint here, and if we want to add a toleration for this, then we can do test2.yaml, and we can say come down here, and all we have to do is just paste in the taint and change that to a toleration, because the taint and the toleration will always mirror each other. So that's a quick and easy way of adding tolerations to your pods. Next, a common question that you'll see is how to create etcd snapshots. So we have to be familiar with the etcd control commandlet and some of its subcommands. Generally, snapshot save and snapshot restore are the two that are most commonly asked. So etcd ctl -- help. I'm not sure if I actually have this. etcd ctl. Okay, so I don't have this installed, but what this would generally look like, first of all, when you're running etcd ctl, you need to ensure that you're running the right version. It should be running version 3 for the purpose of the exam. So when you run any command, you can just do etcd ctl _ API equals 3, and then run the command, which might be something like etcd ctl snapshot save. Then you'll have some path file.db, and the file will be given to you. They'll tell you where it needs to go, and you will have to specify a CA cert, a cert, and a key, as well as the endpoint of the etcd cluster. And you can get all of this information get pods-ncube system from etcd Minikube here, or whatever the name of the etcd node is. Get pods-ncube system --o YAML, or sorry, -o YAML. And we can see there are various parameters that are passed to etcd, and this is where we'll get all of the information. For example, trusted CA file is this one here. The cert is, let me see, key file is here, the cert file is here, and the URL is localhost 23.20.79. So that's what you would pass to your etcd ctl command when you're running your snapshot save. And you can also run etcd ctl snapshot status after you have saved your snapshot, and that will basically verify that the output that you have created is correct, and that it'll tell you the size of the output and so on, but it's just a verification for your sanity to ensure that the snapshot is valid. Next, another key area is control plane and kubelet debugging. So oftentimes we will have to go to kubelet and find possibly SSH into a node, check if the kubelet is running or not. That can be done using service kubelet status. I'm on Mac here, so I don't have an exact replica of the environment. This is obviously going to return me command not found, but we can also check for the kubelet process using psaux grep kubelet. In this case, again, it's not running on my machine, but these commands will work when you're in the correct environment. And generally what you want to do is check what the output looks like from your service kubelet status. Use that to infer any potential reason for why the service is down. You're obviously going to want to first attempt to restart it. If that doesn't work, then it'll probably give you a more detailed output in terms of why it's not working, and then from that you might need to go to a configuration file and modify it. You can obviously again gather more information from your Kube API server. There is some kubelet information here, but generally you're going to get most of your information when you run that service kubelet status. We've already gone over this, but you want to run your pods imperatively with krun. And as mentioned, the key fields are the name of the pod, my pod, and the image. And these fields will be given to you. They'll tell you what name and what image generally to run. One other detail is that you will oftentimes be asked to expose pods using a service, and you can do this imperatively too with kexpose. Just check what this looks like. Again, jump to the examples, utilize them. Let's say we want to expose my pod here, and we run kexpose my pod. If we want a specific name for the service, we pass -- name, otherwise it takes on the same name as the pod. My service, let's call it. We can also specify a port. Port equals 80. And if we want to, we can also specify a type. If we need to expose the pod externally, for example, we can do type node port. In this case, we'd have to dry run it and then expose pod. Yeah, of course you have to define the resource that you're actually exposing, and you'd come in here and just add a node port that you want to use. So if you run dry run server, then it'll actually generate a random node port that you could potentially use if you want to. You don't have to manually specify the node port, but you can do if the question dictates that's what you should do. So you may want to use dry run server and then just come in and modify the node port here, and then you'll be ready to go. You'll also need to get rid of these fields like creation timestamp and so on, because they will be generated each time you run the command against the server. Okay, now I believe this is our last slide. It is indeed. Finally, some tips for the exam. So you want to know the pluralities of fields. So an easy example of this is when you are running, when you're creating any pod using manually created manifests. You should be aware, for example, that volume mounts is plural. This generally dictates that the item under it is going to be an array. Same with volumes. If you go in and you specify that it's volume mount, for example, then that will throw you an error. You need to know it's volume mounts. Obviously you can check the documentation, but this isn't this exam won't allow you to go in, make the error, see that it's an error, then go to the documentation in order to correct it. That's taking too much time. You should be aware that it's a plural field just based on the repetition that you have done via the practice exams. The next thing is to know when to use kubectl edit versus kubectl create. So if we wanted to edit one of our pods, we can do kedit test pod, kedit pod test pod, and let's say we wanted to change something related to the container. We can, let's say we want to add security context. Capabilities and not add ability to change the time, sys time. All right, now we've spent 30 seconds fixing that up so that we have this security context. Go to write or change, we quit out of it, and then we get this error: spec forbidden. Pod updates may not make changes to fields other than spec.containers.image, spec.initcontainers.image, spec.active deadline seconds, spec.tolerations, or spec.termination grace periods. So we can go and edit these fields, but we can't edit anything else. So if we needed to make that modification, our best bet is generally to just get the pod. First of all, get pod, or test pod it was, -o YAML test copy.yaml, save it, then edit, then we can also just delete it now, assuming that it's been test copy. Yeah, it's been written out fine, so we can just delete test pod. Delete pod, always make sure you add your resource type. Pod's been deleted. Now we can open up test pod test copy.yaml. We need to delete a few of these lines because they're not that one. D2D. Anything status and below will also be deleted, and from here we're okay, and we can go in, make our modification to our security context. Blah blah blah. Continue. Okay, next tip: you should have a good internet connection, at least a reasonably solid internet connection. You'd be shooting for minimum 20 megabytes per second. If you do not, you'll find that the remote desktop that you're working with is incredibly laggy, and it's just not going to be a pleasant experience. You probably won't get things done in time. Verifying answers. So I covered this with kauth can I for any authorization related or RBAC related questions. Another good way to do this is to run with the DRS, dry run server environment variable that I mentioned run your create command or whatever command that you're executing with dry run server. That will give you the most in-depth verification that your syntax is correct, and it will also allow you to kind of just review what you've created, make sure that is exactly what you want, and then you can remove the flag and you can create your resource. Finally, when you're editing pods, for example, you want to edit the top level resource. If a pod is deployed as a replica set, you want to edit the replica set. If the pod is deployed as a deployment, you want to edit the deployment. This is something that I ran into in the early iterations of me running practice tests. You may run into a situation. I can just give you an example. Okay, create deploy test, or let's say deploy one dash image equals nginx dash replicas equals 3. Okay, get pods. Now we have 3 new pods. If the question asks you to make a modification to the pod, you don't want to come in here and go kedit pod like this. You want to do kedit deploy and then just give the name of the deployment. And that will be your most efficient way of doing it. So that is everything for this guide on how to pass the CKA. Really hope that was useful. If you have any questions, please leave a comment. Please like and subscribe. And I will have a list of everything that you need in the description. And that is it. I'll see you in the next video.